Hello friends, I welcome you in lecture number 16 on graph theory. In this lecture we will discuss one more example on finding node base in a directed graph. We have discussed the definition of node base in previous lecture. Here also we just revise that what is the meaning of node base. Suppose G is a directed graph, then a subset capital X of vertex set V is called a node base if reachable set of capital X is equal to vertex set V and there is no proper subset say Y of X such that reachable set of Y is capital V. If capital X satisfies these two properties, then we say that capital X is a node base, and we have discussed certain properties of node base in previous lecture. So if you have not seen previous lecture, I suggest you to watch lecture number 15 first and then go for this lecture. Here we have taken one directed graph and we are interested in finding the node base for this graph. So first we write down what is the vertex set of this graph. Here we are having 5 vertices which are denoted by V1, V2, V3, V4 and V5. Now node base is the subset capital X of V such that reachable set of X is equal to V and there is no proper subset of X which satisfies this property. So whenever they ask to find out the reachable node base in a directed graph, then first we should try to find out reachable set of every vertex. So first we find out reachable set of V1. Reachable set of V1 means all those nodes which are reachable from V1, and we always assume that every node is reachable from itself. So we include V1. Then we can see that here it is possible to reach V2 from V1, that is there exists a path from V1 to V2, therefore V2 is reachable from V1. Similarly there exists a path from V1 to V3, therefore V3 is also reachable from V1. And if we extend this path up to V4, then V4 is also reachable from V1 and V5 is also reachable from V1. So all the vertices are reachable from vertex V1, therefore we find that reachable set of vertex V1 is capital V. So if we consider capital X equal to set containing V1 only, then X is a subset of capital V and reachable set of X is equal to V. And what are the subsets of capital X? So subsets of capital X here are empty set and X itself, and this is not proper subset of X. So the only proper subset of X is empty set, and empty set does not satisfy this property that reachable set of empty set is not equal to V. Therefore we find that if we take capital X equal to set containing vertex V1 only, then reachable set of X is V and no proper subset of X satisfies this property. Therefore the node base is set containing vertex V1 only, is capital X equal to set containing V1 only. So whenever they ask to find out node base, it is better that we should start by considering a set having single vertex. If reachable set of V1 was not equal to V, then we would have tried another vertex. Now suppose reachable set of any vertex is not equal to V, then we will try for 2 vertices and we will check whether reachable set of those two vertices is equal to V or not. So in that way we will try to find out node base. And as we have discussed in previous lecture that there can be more than one node base for the same directed graph, but the number of vertices in every node base are same. And we also have discussed that whenever we are writing a node base, and if we have any cycle in the node base, then any vertex on that cycle can be considered in the node base. Here we have taken V1 in the node base. We can consider V2, V3, V4 also. Suppose we try to find out reachable set of V2, vertex V2. Then we can see that we can reach V1 from V2. There exists a path from V2 to V1, this path. Therefore V1 is reachable from V2. V2 is itself reachable from V2, and then V3 is also reachable from V2. So here we write V3 also. Similarly V4 is also reachable from V2. So we write V4 also, and this V5 is also reachable from V2. If we go along this path, we have a path from V2 to V5. Therefore here we find that reachable set of V2 is also given vertex set, and there is no proper subset of this set V2 which satisfies this property. Therefore another node base is set containing vertex V2 only. So you can have more than one node base, but once you find out one node base, you will find that the number of elements in that node base. So the number of elements in any other node base is also 1. Similarly, you can check whether set containing V3 and V4 are node bases or not. And if we check for V5, suppose we check for reachable set of V5, then we can see that there is no edge going out of V5. So the only vertex which is reachable from V5 is V5 itself. So here we obtain V5. This is not equal to V. So set containing only V5 is not a node base. And you can check for reachable set of V3 and V4, or let me find out. It is easy to write down reachable set of V3 and V4. For V3 we check whether every vertex is reachable from V3 or not. So we can go in this direction up to V1. So V1 is reachable. Similarly we can go in this direction up to V2. So V2 is also reachable. V4 is obviously reachable, and V5 is also reachable. So all the vertices are reachable from V3 also. That means reachable set of V3 is also equal to vertex set V. And then we check for V4. V1 is reachable from V4. You can check this path exists. V2 is also reachable from V4 along this path. V3 is also reachable from V4 along this path, and V5 is also reachable from V4. So reachable set of V4 is also equal to V. Therefore we find that set containing V1, V2, V3 and V4, all these are node base for the given directed graph. And if you remember, in previous lecture we had discussed one property of node base, that if there is any cycle in the given directed graph, then we can consider any one vertex from that cycle in the node base. So as we have seen that this V1, V2, V3 and V4, all these are node bases, and all these vertices V1, V2, V3 and V4 are on this elementary cycle. So in this way we can easily write down the node base for any directed graph. All we have to remember is this definition, that find out that subset X of vertex set V such that reachable set of X is V, and there is no proper subset of X with this property. So I hope you will be able to understand this lecture. Thanks for watching.